All right. So today we're looking at 7.3 and 7.5. Next class, we'll come back and do 7.4. So we're looking at perimeter and area, volume and surface area. I'll write that a little better. So we're going to use a rectangle and just generally as our shape as we discuss the differences between the three. So the perimeter, you do not need a formula in order to find the perimeter. All you have to do is add up all the sides. Now there is a formula for the perimeter of a rectangle. We have it right here, 2L plus 2W. Yep, and I have my eraser still on. There we go. So 2L plus 2W is the formula for the rectangle, the perimeter of the rectangle. But you do not need that. All you have to do is add up all your sides. And for any shape, all you need is to add up the sides. And so we talk about calculating the perimeter. We're talking about the outside. In other words, like fencing. How much fencing would you need? The distance around the shape. So that would be your perimeter. We'll talk about the green measurement in a second. This green over in a second, but let's see. Somebody said something in the chat. All right, so somebody said they can't hear me. Am I breaking up for everybody? Is there anybody else's?
No, doctor, I can hear you clear.
Okay, great. So let me, okay, yeah. Thank y'all for responding. I appreciate that. All right, so looking at the area, the difference between the area and the perimeter is that the area is the amount of space that the shape takes up on the inside or two-dimensionally on the inside. So we're talking about the inside versus the outside. And you will need a formula for the area. So before, when you talk about the perimeter, add up all your sides. You may have a formula, you may not, but you don't need one. But for the area, you will need a formula. For the rectangle, to calculate the area of the rectangle is length times width. And then when you talk about the volume, you need a formula for the volume as well. And that's the amount of space that a shape takes up three-dimensionally, if I can get it out. So that's going to be length times width times height. So area is the amount of space a shape takes up two-dimensionally. The volume is the amount of space a shape takes up three-dimensionally. All right. So when it comes to the measurement that you will have for each one of them after you finish calculating, notice that for volume, you will be in cubic measurement. So if you were in inches, it will be cubic inches. For your area, it would be squared. Is that someone talking? That's someone. That's not for me. All right. There you go. So your area is a squared measurement, and then your perimeter will stay in your regular measurement. So if you were in inches, after you calculate your perimeter, it will stay in inches. If you're in area, once you calculate your area, it will be inches squared or squared inches. And then volume, it will be cubic. All right, any questions on anything I've said up to this point?
No, sir.
Thank you. And always, just like before, if I scroll up and someone's still copying, let me know. All right. So here we have find the perimeter and the area. We have this rectangle here. The length is 30 inches. Width is 20. And so for every formula you have, or for every shape you have, there's a separate formula. So no formula is going to flow the same for all shapes. So rectangle has its own formula. Rectangle has its own formula. Triangle has its own formula. Same thing with a circle and so on. So make sure you are matching up your formulas correctly with the shape that you're trying to find this information on. So your perimeter for rectangles, 2L plus 2W. Plug in 30 for L, 20 for W. 2 times 30 is 60. 2 times 20 is 40, and that's 100 inches. Then for your area, length times width, so that'd be 30 times 20, which would be 600 inches squared. All right. Next one, we want to find the area of a triangle. They give us the base as 12 centimeters. The height as 6 centimeters. Formula for the area of a triangle is 1/2 base times height. 1/2 is a part of the formula. So 1/2 times 12 is 6, and 6 times 6, 36 centimeters squared. All right.
Hello.
Hey, how's it going?
I was having trouble getting connected to the Wi-Fi, so I was trying to get to the Zoom call. I was just letting you know that.
Okay. Yeah, that's no problem. Thanks for letting me know. All right. Everybody done with the triangle. If I scroll up. All right. So here we have a trapezoid. We have our top side is 6 feet. Bottom is 14 feet. And then the height is 7 feet. And this is the formula right here for the trapezoid. 1/2 times the height times A plus B. Normally the top side is A, bottom side is B, but notice in here that that is interchangeable. So whether you do 6 plus 14 or 14 plus 6, you'll still get 20. All right. So you do what's in parentheses first. Of course, like I mentioned, 6 plus 14, which is 20. And so we have 1/2 times 7 times 20. Now, if you have a calculator, then you can just put all that in the calculator and you'll get the answer. If you were doing it by hand or in your head, then I would do the 1/2 times the 20 first. It's all interchangeable, as far as multiplication. You can do it in any order. So 1/2 times 20 is 10, and then 10 times 7 is 70. So once again, put it in the calculator. It doesn't matter what order you do it in. But if you're just doing it in your mind or doing it by hand, doing it in a different order may help. All right, questions before I scroll up. Okay, circles. If you see a diagram with a line going through the center from one end of the circle to the next, that's your diameter. Then if we have something going from the center to the end of the circle, then that's your radius. They don't necessarily have to tell you the diameter, but if they give you this diagram and put a 5 right there, then that's letting you know that the diameter is 5. Or in the same fashion, if they give you the other diagram, this one right here, put a 5 right there, then the radius is your is 5. So they don't always have to label it, but if they put it in the diagram as a part of one of your dimensions, then they expect you to know what's going on according to what you see. So the relationship between the two is that half of the diameter is the radius, and then if you multiply the radius times 2, you have the diameter. So if you have just one, then you automatically should be able to figure out the other one. And that's what I was emphasizing over here in the green. If they give you the diameter to be 30, you would take half of 30, and that will give you 15 for the radius. Or if they give you 7 for the radius, multiply that times 2, and that would be 14 as your diameter. So if they give you one, then you should automatically be able to figure out, what the other one is. All right. So when we talk about the circumference formula and the area formula for the circle, circumference is 2 pi r, 2 times pi times r. Area is pi times r squared. Circumference is basically the perimeter for circles. Remember when you're talking about a perimeter, you're adding up all your sides. But when it comes to a circle doesn't have sides. So the circumference is the length around a circle. That's the perimeter equivalent. And then pi is 3.14. If normally when you want to abbreviate it, 3.14. That's going to help us in calculating the circumference and the area. And then even when we get to volume, we'll see pi show back up. All right. So next example, we want to find the circumference and the area. I'm going to give the exact and the approximation. All right, so notice we have this diagram right here for our circle, and it has 20 inches, but it's going from end to end through the center. So it lets us know that our diameter is 20, and we have to calculate our radius. So they didn't give it to us, but they expect us to be able to calculate it from the diagram. So half of 20 is at 10 inches. So to calculate the circumference, we would do 2 pi times r. 10 is r, so that's 2 pi times 10. And let me erase some of this stuff so we can be clear on what's going on. All right, so to simplify that expression, 2 pi times 10, I would do 2 times 10, which is 20, and leave the pi there. So 20 pi inches will be what they consider the exact answer. All right, so simplifying the expression as much as possible with the symbol pi still a part of your answer is considered exact. So be careful with that, because a lot of times people will put in 20 inches and they leave off the symbol pi. And of course, my MATLAB web assignment for you guys will mark that wrong, because it should be 20 pi. Then if you want to find the approximation, you plug in 3.14, and that'll be 62.8. So then I wrote a note in purple. One thing I noticed about WebAssign last few semesters is that they want you to use pi in your calculation, like throw it in the calculator as 20 times pi, and then get your approximation. So be careful with that. I know before this would work, but just be careful. Do 20 times pi in the calculator and then get your approximation. It's going to be close to the 62.8, but it may be a little different. So to be on the safe side, that would be the best way of handling that. So you just do 20 times pi in the calculator and then round it off. Now for the area, we're going to do the same thing, follow the same process, just a different formula. So that's pi times r squared. R is 10. So 10 squared is 100. So 100 pi is going to be the exact. And don't forget inches squared when you're dealing with your area. And then calculate 100 times pi, or 100 times 3.14. It'll be approximately 314. Once again, inches squared. Those be your answers. All right. Questions, make sure we're okay. And so if they ever ask you for exact, they want you to give the answer simplified as much as possible with pi still there as a symbol. And then when they want the approximation, they want you to round it off, calculating with pi for the final answer. All right. Questions before we do a few volume problems. So once again, the key to all of these is making sure when you have your different shapes that you're using the correct formula for the shape that you're trying to calculate with. So here we want to find the volume. The radius of the base of a cone is 8 centimeters. The height of the cone is 12 centimeters. So I got my little diagram down here. My base has 8 centimeters as its radius, and then 12 centimeters as its height. This is the formula for the volume of the cone. 1/3 is a part of the formula. It's 1/3 times pi times r squared times h. Plug in the 8 for r and the 12 for h. Once again, if I was doing this by hand, I would take the 3 into the 12. You know, it's all multiplication, so you can do it in any order that you like. So 1/3 of 12 is 4. 8 is squared is 64. So 64 times 4 is 256. And so 256 pi would be your exact answer. 256 times pi, rounded to 2 decimal places, will be that 804.25. And measurement is cubic. All right, any questions? Very good with that. Next one we have is a cylinder. On bottom, and also take note of what we have on bottom this time versus what we had on the bottom last time. Last time we were dealing with the radius. This time the line goes from end to end on the circle, so that's actually the diameter. So they give us the diameter as 6 meters. Our height is 4 meters. For the volume, to calculate the volume of a cylinder is pi r squared h. So I need r. So I'm going to take half of that 6, which is 3. Once I have my dimensions, I will just go ahead and plug in. So that's pi times 3 squared times 4. 3 squared is 9. 9 times 4 is 36. Once again, here we have that exact answer. Then 36 times pi is 113.097. So always pay attention to your directions, see what decimal place they want you to round to. If they ask you for the 100th place, but you put the 10th place, they're going to mark it wrong. So, make sure you're careful with that. If you're ready to do something like that on a test, I can give you, partial, give you the majority of your points. If I give you 0.8 when you're supposed to get 1, I mean, that's way better than 0. But I wouldn't know unless you let me know that, you have some partial credit, that you would like to see if you can get or something like that, or you got it right when it marked it wrong, something of that nature. We'll talk more about it, when we get ready for this test. Let's see, any questions? Everybody good with that?
Excuse me, Professor.
Yes.
Yes, how did you get on 113.097? I got stuck.
I threw that thing in the calculator.
What did you multiply? 36 times
Yeah,
what?
36 times pi.
Times who?
Pi, this symbol right here. This
Okay,
symbol.
that's 3.14, right?
Yeah.
Okay.
So make sure you can find that symbol in your calculator, because Weber signs sometimes is a little funny. We're using 3.14. Like there's, some decimal places right here that the 3.14 may not give an account for.
Yes.
So make sure you can find that symbol in the calculator and multiply 36 times that, and
Okay.
then round it off.
All right. Thank you.
Yep, no problem. All right, here's somebody in the chat. Oh, okay. Yeah. Oh, I got people saying stuff in here. Okay, not a problem. Not a problem. We got at least one more, I think. Yep, got at least this one more. Questions before we go to it. Make sure we're good. All right, so we have the diameter of the base of a cone is 5 meters, and the slant height is 4 meters. Find the surface area of the cone. Give you a chance to write that out. All right. So they want us to find the surface area of the cone. Surface area formula is right here. S equal to pi r squared plus pi rl. So they give us diameter. That's what I'm calling D. That's 5 meters. And then they give us L. We use L for the slant height. And that's all, in the book. And like I said, if you were to ask Siri, Google, or anything else, or anybody else, they would still give you those same letters and same explanation. We know if we need R, but we have D, then we need to divide that by 2. So R is going to be 2.5. And then we plug them in. Pi times 2.5 squared plus pi times 2.5 times 4. 2.5 squared is 6.25. 2.5 times 4 is going to be 10. I can write that without parentheses. That's 6.25 pi plus 10 pi. Add them together. That'll give us that 16.25 pi meters squared. And then 16.25 times pi. Throw that in the calculator. That'll give you 51.05. And we're in meters, and this is surface area. Once again, your area is going to take you to squared measurement. All right, questions? Any questions? That's it. So the main thing with these two sections is making sure you know how to use the formulas by, plugging in and calculating, and then attaching the right formulas to the correct formulas to the correct shape, so their respective shapes. So remember, every shape is going to ask for a different formula. When you do the test, you should have access to those formulas. I'm not taking that away from you. So you don't have to memorize them. You just need to know how to use them. All right. Questions on anything? Questions on anything?
Yes. Yes, I have another question.
Mm-hmm.
You divided on this last one. You don't multiply?
Divided. Which one? What you mean? Where?
The one we just did. The 5 meters diameter, and then the length is 4 meters. The slant height.
Yeah. Now I divided that 5 by 2 because we needed the radius. So they gave us the diameter in 5 meters, and
Yeah.
in order to get the radius, I needed to divide it by 2. So that's what I did that there. If that's what
Okay,
you're talking about.
okay, so when you get the radius, you have to divide.
Well, it depends. Yeah, if they give you the diameter, yes, because that's half of the radius is half of the diameter. Because our formula right here calls for the radius, but they gave us the diameter. Now, if they
Okay.
give us the radius from the beginning, let's say if they said the radius was 5, then we would have just used the 5.
Okay.
Because, and let me go back here, because this is our diameter, but the radius is half of that.
Okay.
And so, yeah, it just depends on what information they give you from the beginning. And that's what would dictate that you divide that by 2 or not.
All right. Thank you.
Yeah, no problem. All right. Anybody else before we close out today? That was 2 sections, so I won't hit you with too much more. Everybody good? Everybody straight? Don't forget, if you do stuff in WebAssign and you have questions, you can always feel free to bring them to class. And, we'll tackle it before or after class, or I might set aside next class to do all of them. Just depends on how many questions that we have going on.
I have a question. Can I speak to you after class?
Sure, sure. So before we close out and address her question as an individual, everybody good? Everybody straight? Don't forget, like I said, check out that Super Bowl question, the extra credit question that I posted. Like I said, it can't hurt to shoot your shot, even if you don't know anything about football. 50-50 chance you can win that thing and get a couple points added to your test score. Outside of that, you guys have a great weekend. Be safe. I will see you on Tuesday.
You too.
All right, you take care.